Testing 1, 2. Okay, boss. Thank you so much. I did not come with my scrubber, did I? Okay, so zafuta na chani manja. Eh? Okay. Atazawa shai. Okay, so welcome back. So first of all, when I was recording, these videos won't just be for other people. You yourselves, you can make use of them as well. We still have about 2 months or so. In case you miss something, these are some, I'll upload them somewhere where you can subscribe and sort of watch them. But they're mainly meant for audio. So what I want to do is, or what I want to say is, as time goes to 17, 30, 40, it starts to get dark. So this means that we need to be starting at exactly 17. Latest is 40. We need to be out of here, otherwise very corner. So the stuff that we were doing yesterday, remember we were calculating, right? Yeah, I mean, I could see here, but things were getting a bit darker. So I want to just start first by recalculating what we did yesterday. And also Mufasa is going to benefit because he wasn't there. Okay? Then secondly, the guys that are at the back there, whoever is coming in, please make them move in quietly. Are we together? So we don't disturb the class. So they can just come in, they start copying, and then we move like that. So the example that we had the last time we met, we said that the volume given was 6 cubic meters, right? And what else was given? The weight? Okay. The weight given was 47 kilonewton. Huh? So yesterday we spoke of prefixes. So prefixes are just a scientific way of seeming smart, all right? So instead of writing a lot of zeros, you put a prefix and then you cut everything down. But what a kilo is 1,000, right? So in short, this can also be written as 47 by 1,000 newtons. When you are calculating, make sure that prefix is unwrapped. So can you just stand next to when they're coming in so they keep quiet? Okay? Are we together? So when you are calculating for this particular course and whatever it is, where prefixes are concerned, put that value in and then you work your way up. Okay? And then we were asked to find the mass density. We were asked to find the specific weight and the specific gravity. The class that we had yesterday, Madam, hello? Can you just, if you're sitting there, just sit. Don't come this side, yeah? Just sit that side. Are you here? Okay. So try to maintain whoever is coming in to move quietly. Are we together? We need to move with time. So we were given a task of finding 1, the mass density, 2, the specific weight, and then 3, Can we just settle down quietly? Don't make noise. Just sit, get your book, start writing. Okay. So already, what I said yesterday is that these properties of a fluid, one, you need to know what they are and how they're related and how we denote them. So if you miss yesterday's class, then this looks strange, and everything just looks strange, right? But we're just trying to, have a recap, also just to maintain what we did. Okay, so the first question we said, or answer we can find is, look at what you're given, then what property can you find there? If I have a volume, I have the weight, then between the three, I can only get the specific weight, not so? Yes. All right, so one, we say specific weight is equal to the weight over the volume. And this, we just divided a 47,000 over a 6 cubic meters. So this is the Newton, because you have your prefix there. So let me just work with that. So we're just doing a recap of what we did yesterday, and then we'll move on to something different. All right, so your answer, if you went through this material, what are the units? Not so. Okay. Now that you found the specific weight, yesterday we said there's a relationship between specific weight and the mass density. And we say that specific weight is equal to what? Mass density by gravity. So you can move on to say, I'm looking for mass density. And so I can have my specific weight being divided through by gravity. And so I have my 783.33 divided by a 9.81. Was it a 79? Point 9, yeah? Are we together? So, and the units for mass density? What are the units? All right. And then the relationship, which is the third point. So relative density is just a relationship between the mass density of a subject or substance, right? And we're relating it to the mass density of water. Not so? Okay. And so we can pick either specific weight or mass density to do that. So let's try to work with mass density. And that was oil, not so? Yes. So we can say mass density of oil divided by mass density of water, which is a standard. And what we have over here is a 79.9. What is the mass density of water? If you missed, but I'm looking at the numbers, they're looking good. Mass density of water, we may not give it to you, but then we expect you to know it and to have it. So there are things like mass density of water, also know the mass density of oil, and maybe air. Maybe just about those 3 or 4. Are we together? If you know the mass density, then you can also get the specific weight. So in a test, quiz, or exam, if you're not given, we expect you to have that value within you. Okay, 79 point. Okay, what are we getting here? 0.1? Is this what you found yesterday? Yes. What did we find yesterday? Yes. 0.8, right? Yes. Where have we missed it? 799. .8. Okay, so this is just a recap to cover for what we missed yesterday. So I was saying that when we're reaching 17, 30, 40, it gets a bit dark, so we can't see anything there. Are we together? Today's material, okay? Let's talk about what we call, or what's known as hydrostatics, all right? Hydrostatics. Okay, so pressure. So let's write this statement. In fluids, we use the term pressure to mean full colony. In fluids, we use the term pressure. In fluids, we use the term pressure to mean full colony. The perpendicular force exerted by a fluid per unit area. The perpendicular force exerted by a fluid, the perpendicular force exerted by a fluid per unit area. And that's how we define pressure in this course. So I think yesterday I mentioned that one terminology can be understood differently from one course to the next, not so? Okay. All right, so then say some common some common units. We have one bar is equal to a 10 raised to the power 5 pascals. So these are measurements of pressure, not so? And another very common unit of measurement of pressure, and I'm giving you this because from time to time as we get deeper into the course, we'll be making use of them. The other one, very common, is 1 atm. What's 1 atm? What's that? Atmospheric pressure, right? So 1 atmospheric pressure is equal to about 100 over of pascals, okay? Are we there? Okay. Let's talk about Pascal's law. What do you remember Pascal's law? And I'm thinking this is not the first time we are hearing of it, is it? Who remembers what from high school about Pascal's law? Yeah? Chinaibara? Yes, ma'am, sir.
Is same at any angle.
Something like that. Did you read this like when you got here, or it's what you remember from high school?
High school.
Which school were you at?
Just in kind.
Who?
Just in kind. Along
Mansa Road. Okay. That's impressive. That's really good. Yeah. So Pascal's law says that in a fluid that's at rest, at any given point in that fluid, pressure is the same from all different angles. Okay, so let's try to get what the law actually really states. So let's write this. This law states, full colony, this law states the pressure at a point in a fluid at rest, the pressure at a point in a fluid at rest, the pressure at a point in a fluid at rest is the same in all directions. Is the same in all directions. Is the same in all directions. So we're going to sort of have a simple illustration of how scientists got to that. So it's a very simple, not really simple, it's manageable. And if you've looked at the past papers, this question sometimes, it's shown up. So if you understand it, then you are doing fine. So let's write this. To show this, we will consider a very small wedge To show this, we'll consider a very small wedge of fluid surrounding the point. A very small wedge of fluid surrounding the point. This wedge is unit thickness into the page. This wedge is unit thickness. This wedge is unit thickness into the page. All right? So we're talking about Pascal's law. So we're trying to illustrate, and this is the wedge we're interested in. Okay, so for us to fully understand and show that Pascal's law exists at a point in a fluid that's at rest, pressure is the same from all directions, this is how we go about it. So we get a wedge in a fluid at rest, and then we're trying to show that this pressure and the pressure Y and the pressure S, I think, yes, are acting from different directions, but they are all the same. That's why the fluid is at rest. Are we together? Okay, so how we go about this is that we're going to sort of remind ourselves a bit of what we did way back. So the things I would want you to keep in mind, one, we know that pressure is equal to a force over area, not so? So for us to get the force, which is what those pressures are, we're going to say pressure is equal to area. So for us to get the value of pressure or the force, we're going to multiply the px by the change in x. So change in x, if you're hearing this for the first time, it's just a change in distance. So we're covering a certain distance. So when we're talking about x, we're talking about it starting from here, ending there. And then what's here, this is the pressure acting at x. But we can't work with pressure. What's best to work with is force. Why? Because what we know is that the summation of forces in the x direction should be 0, for instance. Okay? So we can start with 1 and then end with 1. So x is changing in that direction. And what can we derive from it? So this would be a bit of mathematics and a lot of just the physics that we did. So the change in x, which is going this direction, first of all, we are starting with the py to multiply with the change in y. That's going to give us the force in the x direction. Are we together? And this is coming from here. If we multiply the force, the pressure by the area, we get ourselves a force. And we're using force because it's what helps us to solve what we're looking for. Forces in the x direction, for something to be stable or stationary, it means that the forces moving clockwise and clockwise, they are the same. Yeah? So if we are going to say pressure y multiplied by the change in y, maybe this is a positive, subtract. This is the force except it's at an angle, and this is the reason why we're having a theta here. But this force can be resolved into the x and the y. Are we together? I'm seeing a lot of what's going on here. Okay? So how then can we resolve this pressure into one which is y and then one which is x? You remember the SOHCAHTOA, not so? SOHCAHTOA. This guy, for this wedge to be in place, needs this other guy to push, and they need to be the same. Can I repeat that? This force which is going this way can only work against that force for things to be stable. The force that is pushing upwards can only work against this one so that things are stable. So we need to be able to resolve this force into the x and the y. Are we good? So this is why we're going through this process. If I multiply the change in y and the pressure in y, I'm getting a force. And it's going that way. But then from this guy, how do I resolve this force into one which is acting in the opposite direction? If this is my angle, then I'm going to be working with the sine, not so. It's the opposite. If I'm standing here, this direction is basically the same as that. So this is the opposite that I'm looking for. Are we together? So I'm going to say sine opposite, which is the force that I'm looking for. Sine theta opposite is equal to so I'm going to say sine theta is equal to opposite, which is what I'm looking for, divided by hypotenuse. What is the hypotenuse? PS, right? So for me to get the opposite, I'm going to say sine theta multiplied by PS. This is just a force. And this force is acting in relation to the change in S. So if you multiply the two, you get yourself a force that is acting in that sense. Are we together? All right, so I'm going to say sine theta dot PS multiplied by the change in S, all right? Change in S. Remember, it's the pressure that you're finding, and you're multiplying it by the area. For us to find the force, we're multiplying the pressure and the area. This is what we're trying to do, and this is why I wrote this little piece here. Pressure multiplied by the change in area gives you a force. So the whole lot of this is a force. And then whatever we have done here is just a pressure, so we need to multiply this by the change in the area. So this is why this guy sits here. And this is supposed to give us a 0. And then we're going to move on to say if sine theta sitting on this wedge. The opposite is a change in y, and the adjacent is a change in x. So change in y over change in x. So we can replace whatever is going on here into sine theta. Not so. Who's lost? I can see a lot of faces. Yes, sir. Where? No, you can't be lost the whole way, sir. There has to be one where I can meet you halfway. This opposite? Sokatoa, sine. So if I'm standing here, remember, I'm trying to resolve this pressure into that force which is acting against this one. Did I mention that we got good mathematicians in here? I didn't say that. This is what we're trying to avoid. Okay? So for me to resolve this pressure, I have to work with sine. If this is my theta, opposite is this, which is basically the same as that. And then there's hypotenuse, which is that. This is not even a fluid mechanics now. It's just, it's math now. And are we good? So for us to knock out sine theta, we have to replace whatever is going on here from here. And you ask me, where is the sine theta coming from? If you're going to borrow your wedge and going by the sine, so sine theta is equal to opposite, which is the change in y, right? Divided by hypotenuse, right? So this is sine, or the change in s. So this is what we have here. So if we move in and say py dash change in y minus, so sine theta is going to replace what's going on here. Change in y divided by change in s ps. So this guy will cancel this one. We're going to have a 0. So when it cancels, it just remains like this, not so. So this cancels that, the PS, and then the sign remains that way. So what this means is that you can take whatever is going on here to the other side and say py dot change in y is equal to ps change in y. This guy can go with this. So you can say therefore py is equal to ps. So meaning the pressure coming from x is the same as that coming from y. So that is one way you can prove that the pressure from here and there is the same. So what we have done in the x movement, we can also do in the y movement. So if you didn't get the first part, pay attention, we get the other one also. You guys are engineers. This should be child's play, not so. Okay. So we move in to say the change in force of y should be equal to 0 for a wedge to be very stationary. Okay? So what's going to happen is that we're changing in y, so we're interested in the px. So pressure x dot the change in x minus. So for the pressure or the wedge to be in position, it means that the pressure from x needs to have a counter force, not so. And how do we get this? If this is going up, the only force that can come out of PS is the one that is forcing down. Can I repeat that? For our wedge to be in position, for something to be in position, it means that whatever is coming from the left is the same as coming from the right, right? Yes. And that's what we're trying to prove. So if pressure going up has made this thing to be stationary, it means that there's some force on top that is pushing with the equal size. Of these two, this is the one that is forcing down perpendicular. And in physics, we say that we are resolving this force into the x and the y. You've never done resolving of forces before? You have. I've been a student as well. Or is it a pew-pew? But then why did you do this? You know about SOHCAHTOA, right? Yes. So why do you think you're using that? You were resolving forces, amongst other things. Okay, so from this pressure, how can we resolve this pressure to give us that component? It's cos, not so. Because if I'm going to say cos theta adjacent is this one, so adjacent. And this is the opposite. Divided by hypotenuse, then I'm going to get my adjacent. So again, if I come down here, I'm going to say cos theta is equal to adjacent. So if you don't know where adjacent comes from, if you're given a triangle, go back and revise this work. So adjacent is the one that is attached to the angle that you're dealing with. Divided by hypotenuse. So hypotenuse is our PS here. Are we together? Welcome to engineering. Okay, so for me to get my adjacent, I'm going to say cos theta multiplied by PS, right? And so I'm going to get my adjacent facing down as the pressure. Then I multiply it by the change in S. Remember, if you're trying to find force, you're multiplying pressure by the change. Pressure by the change. So I have found my pressure to be cos theta PS. I just need to multiply it by the change in S. And so I come here. So I'm going to say my cos theta dot PS, then multiply this by the change in S. This should give me a 0. But I know what cos theta can be. If I stand here, my cos theta will be, what is my cos theta here? Adjacent, which is change in x, right? Divided by hypotenuse, which is a change in. And then I'm going to carry this and then replace it with the cos. So I'm going to say my px is equal to, minus, so I'm going to replace this with that. So change in x divided by change in s multiplied by pressure in S multiplied by, so this guy and this guy will go. And so I'm going to remain with Px is equal to Ps change in X. And so this one can go with that one. Therefore, I can say my Px is equal to P. And if I know that my Ps was equal to Py, I've got every right now to come and say Py is equal to Ps, which is also equal to Px. This is how you prove Pascal's law. This is how you prove that a point in a fluid that is stationary has got forces acting on it in all directions, and they are all the same. If you have looked at your past papers, you find this question. Handsome marks for it as well, about 15, 20, depending on how the test is. But then again, I understand if this is the first time you're looking at this, it's a little overwhelming. I have been in your seats as well. But the more you go through it, the easier it looks. So find time to just go through the questions, the process itself. The module has a very similar process that I've gone through. So take your time alone. Try to fully understand it. If you try this for an hour, you're not getting it, then get some counsel from someone. Also, I don't know how you guys study. I always tell students that if there's a group of you, don't always wait up until you're a group for you to go and study. In that group, there's always a guy who knows everything. So for you, you'll be there like you're a student all together, you're learning. But if you don't put in the effort to do your own practicing, it becomes hard. So if you're a group, work individually. Are we together? And then you meet, you bring in your concerns, you bring in your problems, you bring in your challenges. And then you move on. If there's somewhere where someone has got a question, then you move or you solve the question together. All right, any questions? Sir, we've done this twice. Are you still asking where what is coming from where? Kakuru Kenny boss. I was at Kawedi Nyanja. At Mangusukani. At Kakuru Kenny. Time is gone. Feel free. Where? From here to here? From here to here? These ones? Okay, Appa, you understand? All we did here is that we replaced cos x, cos theta, I mean. And cos theta, someone is asking a question, you may face the same problem. Huh? We just replaced cos theta. And how do you get cos theta? You get it from the wedge that you've been given. If you understand SOHCAHTOA, and this is your theta, cos says, or SOHCAHTOA says adjacent. Adjacent is this one. Adjacent is the side that is in touch with your theta, right? Now I'm teaching mathematics here. Who's taking maths? Who? Okay. Adjacent is a distance that is attached to your theta. So which is a distance? It's x, right? This is why it's sitting here. Over hypotenuse. If it's a triangle the way it is, this guy will always be the hypotenuse. So there's a change in S. Change in S is starting from here going all the way. And once you get this equation, you just come and replace it by that. So you're writing everything except you're replacing and you're changing that. Once you do that, you discover that there are common variables that are able to cancel out. So changing S will go. If you wanted, even just from here, you can still cancel. So that you guys just remain with the PS, which is the next point. Yes, sir. Guys.
Actually, how that PS jump to?
You know there's a zero here, right?
Good question. It's supplied of the negative. Since negative is attached to it's a multiplication which is taking place here. PS and change in x, these are attached. So they are attached to with the sign negative. So once it crosses the equal sign, it becomes what? Positive. So both of them they will become what? Positive. You understand?
Yeah.
So you're a teacher? Because I don't think I would have explained it that way. At this point, I genuinely do not, I wouldn't expect you to ask me that like we were jumping. Why? Yeah, but you get the point, right? Are you clear? So, the dots are multiplication like he said. So these guys are attached like he said. So anything attached, then there's a negative sign. If it goes to the other side, it changes the sign. This is like a no-brainer. We've been doing this since grade 1. Which schools were you at? So, here's the thing. I will take my time because we are getting information that we're putting somewhere and for you guys to also make use of. This is a question on its own, just how to prove or just to prove Pascal's law. Find time to fully understand what we have done here. If you're solving this, it won't even take you more than a page. Even actually half a page, you'll be able to solve this question. So find time between now and when we're meeting when?
Tuesday next week.
Tuesday. Yo, anyway. I may not be here, but we'll see. We'll see. If I am not, then we've got more time to go through this if you haven't. All right, so thank you so much. Unless there's a question. Okay, yes, sir. I repeat what he said. Okay, so the question he asked was, how did the negative become a plus, right? Or go the other side? PS and change in S, if there's a dot, it's a multiplication. So anything that is on the other side of a negative, they are attached in somewhat. Okay? And if that is the case, you're just taking to the other side. I don't know why you're interested. You're even taking a video. Wow. It's got what? Okay, guys, so we'll see you next week, and I will give you something to. All right, we'll see you. Secure it, huh? Leave it there. So you erase this when you're done.